Selection sort is a simple and efficient sorting algorithm that works by repeatedly selecting the smallest or the largest element from the unsorted portion of the list and moving it to the sorted portion of the list. What do I mean by it? We have an array of 5 elements: 64, 25, 12, 22 and 11. Now we apply selection sort to sort the array. The whole array is traversed from 0 to n-1. On the first traversal, the element at index 0 is selected. Then we check if there is an element in the array which is smaller than all the elements in the array. In this case, we have 11. Replace the element at index 0, that is 64, with 11. Now 11 is sorted. In the second iteration, we select the next element, that is 25. Again, we check if there is an element smaller than rest of the elements. Yes, we have 12. You might ask, 11 is smaller than 12, but 11 is already sorted, so you do not have to include it. Swap 25 with 12. Now 11 and 12 are sorted. Now at the third iteration, we select the next element, which is 25. Again, we check the smallest element. In this case, we find 22. So swap 25 and 22. Now 11, 12, 22 are sorted. At the fourth iteration, we select the element at index 3, that is 25. Now we check the smallest element. Here there are no smallest element than 25, so no swapping takes place. The sorted elements are 11, 12, 22 and 25. At the last iteration, we do not need to check any conditions, as we already know that it is the last and the largest element in the array. Hence, the array is sorted. Now, let's look at the code for this algorithm. We have a basic structure of a C file. We have included the header file. We have a print array function which just prints the array. In the main function, we have declared an array to work with. We have a variable n which contains the size of the array. At first, we call the print array function which prints the array before sorting. Then we call the selection sort function which sorts the elements of the array using the selection sort. Then we again call the print array function to print the array which has been sorted. Now we implement a swap function which just swaps the variables x and y given to it using a temp variable. Then we implement the selection sort function which takes arguments array and size of the array. In the function, we create a for loop which runs from 0 to n-1, that is n-2. In the for loop, we have a variable called minimum index which contains the current ith element. Below the variable, we implement another for loop which runs from I plus 1 to n. In the for loop, we check whether the current element or the jth element is less than the minimum element. If yes, then we update the minimum index element with the current element or the jth element. Then after the for loop, we check whether the minimum index is not the current ith element. If it is not the current ith element, then we swap the minimum index with the ith element. Hence, the array would be sorted. Now, let's look at the output. Here you can see first the array was not sorted. Then after running the selection sort, the array is sorted. The source code is in the description, so do check it out. The time complexity of this algorithm is big O of n square, as there are two nested loops. The advantages of selection sort is that it is simple and easy to understand. It works well with small dataset. Contrarily, selection sort has time complexity of big O of n square in worst case and average case. It does not work well on large dataset, and it does not preserve the relative order of item, that is, it is not stable. To know whether you have mastered selection sort, try to sort the array in descending order, that is, from highest number to lowest. If you were successful, then congratulations, you have mastered selection sort. If you fail, do not worry, rewatch the video and understand the logic behind the algorithm rather than focusing on code. Eventually, you will succeed and become a master of selection sort. Finally, congratulations and signing out.